Hey guys, today we're going to talk about reflections. A reflection is a type of transformation. So let's go ahead and get our definition settled in right here. A reflection flips a figure over a line of reflection in order to create a mirror image. Okay? When you look in the mirror, you will notice that your reflection is flipped around, so that your right hand is now flipped around and it's not looking like it's on the left. Okay? So when we do a reflection of a shape on a coordinate plane, each reflected point of the figure should be the same distance from the line of reflection. There we go. That's an L. Looks like I crossed it for some reason. That's okay. All right. So let's see what that looks like by doing some practice problems together. Okay. So let's take a look at number 1. We have triangle WXY. Now there's another piece of important information here. We need to know which line we are reflecting over. Okay. We are going to reflect over the y-axis. So that means that this y-axis right here is behaving like a mirror. And we're going to do a mirror image on the other side of that mirror. Now, we can also mirror over the x-axis and go the other direction, which we will do in just a minute. Okay, so basically, what we're going to be doing is, you see the W right here? If W was looking into this mirror, you see how it's 1, 2 spaces away from the line of reflection? That means W prime needs to be 1, 2 spaces on the other side of the line of reflection. So you can see those 2 points are looking at each other through the mirror, and they're the same distance away from that reflection line. So we're going to do the same thing. Here we go. We have Y. Now Y is 2 spaces away from the reflection line. So on its reflection, it's also going to be 2 spaces away from the reflection line. There's Y prime. X is 7 spaces away from the reflection line. So we're going to make X prime 7 spaces away on this side. Now notice, when I did all of these points, I just went straight across the reflection line. It is a straight line. And there, if I put together my triangle, you can see that we have a mirror image on the other side of the reflection line, just by making sure that the point is the same distance away from this reflection line in the middle. Okay, let's go ahead and record the points for each of these. Okay, in the pre-image, we have X, Y, and Z. X, right there, is at 7, 4. Y is at 2, 2. And Z, oh, there's not a Z. It's X, Y, and a W. Whoops. Come on, Miss Jones. W is at 2, 6. All right. Now, we're going to put the points for the image. Okay, so that would be X prime, Y prime, and W prime. All right. X prime, the reflection over here, is at -7, 4. Y prime, right there, is at -2, 2. And W prime is at 2, 6. Oh, that was the original. We want the W prime is at -2, 6. Okay, there we go. Now, as we're looking at these numbers, I want you to see if you can notice a pattern of how we reflected it. Okay, so all of the x values, look at these x values. We had 7, 2, and 2. What happened in the image? Well, we had negative 7, negative 2, and negative 2. It's like they were the same thing, but now the opposite. Instead of being positive, now they're negative. Okay, so I'm going to put they are opposites. Okay, from negative. They're negative now, not positive. Now what happened to the y values? Well, we had 4, 2, and 6. 4, 2, and 6. They stayed the same. All of our x values stayed the same. Interesting. Okay, so when we are representing this algebraically, again, this is what you would do if you write it in math language with symbols, kind of like how you would if you were coding it into a computer. Okay, we would say that x, y is going to turn into the opposite of x. So if x was negative, now it's positive. If x was positive, now it's negative. We're going to just do the opposite. And y is going to be exactly the same. Okay, so this is the notation that tells us whatever x was, we're going to do the opposite. If this was positive, this is negative. If this was negative, this is positive. This negative right here, think of it as doing the opposite. And the y value is going to stay exactly the same. Now this only works, this rule only works when you are reflecting over the y-axis. So I'm going to highlight that bit of information right there, because that rule works only when you're going over the y-axis. It's going to look a little bit different when we do number 2, and we are now reflecting over the x-axis. Okay, so here we have triangle DEF, and this time the reflector line, or the mirror, is not y. So this time the x-axis is the mirror. So when we mirror, we're going to be going over this line. So this one is going to reflect right here-ish. So D is 1, 2 spaces away from the mirror. So its reflection should be 1, 2 spaces on the other side. There's D prime. F should be 7 spaces away from the mirror, but in this direction. So F prime is right there. E is also 7 spaces away from that mirror, so it should be 7 spaces away from the mirror on this side. There is E prime. So here's my rectangle, or sorry, triangle. It has been reflected like a mirror onto the other side of the reflection line, which was the x-axis. Let's go ahead and record the points in our table. So we have triangle DEF. D is located at 2, 2, 2, 2. E is right there. It is located at x is 7, y is negative 7. And F is located at 2, negative 7. Now, let's go ahead and look at the image. Okay, so the D prime, the E prime, and the F prime. Okay, D prime is at 2, 2. Hold on. We made a mistake. What did we do? Oh no! There's a negative here. This one should be 2, negative 2. Oops. There, fix that mistake, because these are not the same point. D is at 2, negative 2, and D prime is at positive 2, 2. Okay. E prime is at positive 7, positive 7. And F prime, right there, is at positive 2, positive f. Oh, positive 7. Okay. Now, again, as we look at these patterns, let's see if we can notice anything interesting. In the x-coordinate, 2, 7, 2, 2, 7, 2. Everything is exactly the same. There are no changes. So all of the x values are the same. The y values went from negative 2 to positive 2, from negative 7 to positive 7, from negative 7 to positive 7. So again, we did the opposite. Okay? Now, even though this might look a little funny, we went from a negative to a positive. When we represent it algebraically, we're going to do it like this. So we're going to start with xy is going to go to, we said that the x values are the same, so we're going to leave x where it is. The y values are the opposite, and we show that by putting a negative number out in front of the y. Now you might be thinking, Miss Jones, that doesn't make any sense because these numbers are positive. So I'm going to demonstrate to you why opposites are always shown with a negative. Okay. So we're going to do that down here. Let's take our first example, negative 2. If I were to put a negative out in front of it, the two negatives would cancel together to become a positive. So we always show opposites with this negative sign right here. Whenever you see this, you know to do the opposite of what happened before. Okay, let's go ahead and keep going. Here, we are going to be using this reflection, and we're going to be answering some statements, okay? Let's do this. Give a verbal description of the transformation. Okay, so if we start right here, this is the image, or the pre-image, and it went here. So what happened? Well, that was a reflection. And when we talk about reflections, we have to say what the mirror line was. This was a reflection over the y-axis. So if we were going to show this algebraically, I'm going to use my notes. And remember that when we went over the y-axis, this is how we show it algebraically. xy goes to the opposite of x, and the y's stay the same. Okay, list each of the following as changed or stayed the same. Did the size of this triangle change? Nope, didn't change. Did the orientation, or the way the figure was facing, change? Well, yes, it did. It's now facing in a different direction. Did the vertices change which way they're facing? Why, yes. Yes, they did. They're now facing in different places. All right, so here we go. Bella and Scott are arguing. Bella says this is a translation because it's scooted, but Scott thinks it's a reflection. How can you tell the difference? They're just rectangles. Ah, the important thing to notice here is where O and O prime are. If it was a translation, O would have gone all the way down and been in this location. But it's not. It was the same distance away from here. So I can tell that this is a reflection. Now, here we go. Triangle ABC has the coordinates shown in the table. Miguel wants to reflect the line using this rule. Okay, we can do this. Now, as we look at this rule, it's asking us what is the line of reflection. Let's match this rule with one of the ones that we did before. Which one is it? Looks like it's this first one. And the first one says we are reflecting over the y-axis. Next, we need to list all of the coordinates in the table. Okay, let's do this really quick. First, all of the x's need to be the opposite. -4 to 4, -5 to 5, -1 to 1. And the y's